write a short story on a street cat helping a house mouse. Here you can see the writing animation, and then you can see word by word it is appending, and we also have a copy icon. So once the prediction is completely done, this writing icon will go away. And also I cannot type anything here because this is disabled, and also the icon has been changed for the send button. Okay, here you can see the generation part is done, so the writing animation has gone away. Now let's ask it one more story. Clock helping a girl to understand the importance of time management. In the silence of a forgotten corner, I detect a constant heartbeat. Okay, you can see it's generating a story in the form of a poem in a very poetic way. Okay, it is done. Hey guys, welcome back to another video. In today's video, we are going to create an AI chatbot that can write stories for us. In this project, I'm going to build not only the backend but also the front end. I'm going to use Flask framework to create the front end and connect it to our OpenAI backend. Because we are using Flask, we can deploy this directly on any cloud platform as a web app. By the end of this video, you'll be able to understand how easy it is to build a chatbot with OpenAI and Flask. So let's get started. Let's create a GitHub repository. New. I'll give it a name as AI Story Writer. Let's create. This is done. Let's go ahead and clone this. Git clone paste. Oh, I already have it. Okay, it's here. Let's open that in VS Code. I'll open a new window of VS Code, go full screen, file, open folder. AI Story Writer, open. Let's go ahead and start creating our files. The first and foremost thing that we need is requirements.txt. Okay, so let's create a requirements file. The first thing we need is, as I said, Flask, OpenAI. We are also going to need LangChain community, and python.env. Let me just quickly check if it is only .env. python.env. Okay. Okay. Apart from these, I think we already covered everything else. So these are the only things that we need. Let's go ahead and create an environment, and let's install all these requirements inside of that environment. To do that, I'll have to create an environment first. I've already got Anaconda installed in my machine, so I'll just simply create a new Anaconda environment. If you are on Windows or if you don't have Anaconda, then you can simply use virtual environment as well. If I go to my website, scroll all the way down, here you can find environment basics. Okay, here is the command to create it with Anaconda. If I scroll down, you can find virtual environment commands as well. Okay, Control J. Let's collapse this. Clear everything, and I'll paste the command here, Python version 3.11, and I'll give the name as writer underscore env underscore AI. Okay, so this is my environment name, this is my Python version. Let's create this environment. Okay, right now it is asking me if I want to proceed further or not. Press Y, hit enter. But for now I'm just going to press no, because I've already created another environment and I've already installed everything in there, so I'll just use the same one, but the steps are going to be exactly the same from this point onwards. So I'll say conda deactivate, because right now base is active, so let's deactivate that. Okay, that is gone, it's no longer here. Now I'll say conda activate writer underscore env. Okay, this is active now, Now let's do pip install -r requirements.txt. This will install all of the different requirements that we have specified here, and if you want to install something in a specific version, you can just give it like this 0.1.32, something like that. But right now I'll just go with the latest versions. Okay, everything is already installed here, so that's why you'll see requirements already satisfied. Let's clear everything. Okay, now let's create a Jupyter notebook and use this environment. I'll create a new file, select Jupyter notebook. Let's save this notebook in the same directory. I'll save it here. Okay, it is still connecting to the kernel. Okay, that is done. Yeah. Okay, here we can see that it is up and running. Let's delete this. Now let's create a .env. env. I'll give token equal to example value. I'll save it. From .env import load.env. So basically all of our credentials, tokens and everything will be stored inside of this .env. Let's call this and then I'll just print it. Okay, this is working. Now let me replace all of we also need a couple more things. Token, host, model name, all the three. Okay, this is done. I'm going to replace all these different empty values with our actual credentials. Let's restart the kernel. Okay. Okay, I've run this. If I print my token host and model name, you can see all of the different values that we have given in the .env file. These are going to be essential for connecting to OpenAI. Now let's directly jump on to OpenAI. First, we're importing the OpenAI library and then we're establishing a client to connect to OpenAI. This is where I'm passing my token and host. Whatever we have read in the environment variable so far, they'll be passed here. If you're using OpenAI directly, then you don't have to pass any host, but since I'm using it from a different provider, I'm using it from Databricks, so I'll have to give the host in the connection string. Next up, we have messages and then the client.chat. So the client.chat is for LLM usage. You do have other modules where you can request for image generation, text to speech, so on and so forth, so on. Okay, here we have messages. This is where we are going to store all of the different conversations that have happened for every session. You can see system and user as two different roles. System will store all of the instructions that you're giving, and user is what you are giving the input to the LLM. Suppose here I've written it as you are an AI assistant who can write poem. Now whatever input that I'll pass in the user dictionary, the same thing will be considered along with the instructions that I'm passing in the system. So here I'm saying you're an AI assistant who writes poems, and I'll pass the user content as cat. Suppose if I change the cat into something else, then it will write a poem on that new one. I don't have to explicitly mention it again. Okay, let's go ahead and test this entire thing. Uh, so that is about the user where you have only two different roles, and we have client chat completions.create where I'm passing all of these messages, all of these conversations, my model name and stream equal to true. For now, I'll just comment this part because when we are running it in a Jupyter notebook, it's a bit difficult to visualize. It's going to get a bit messier actually. So let's run only this part, which will give out the entire answer at once after generating all of the words. Let's run this. That's taking quite a lot of time. This is one big disadvantage that you get when you don't use a stream. And here you can see it has generated a very long story. So this is kind of a disadvantage when you don't use stream. You'll have to wait for the entire answer to be generated before you can see it. But if I'm using stream, what happens is it'll start printing word by word. So first it'll print here, then is a poem about. So each and every word will be presented to the user in a live fashion, in a streaming fashion. So it reduces the latency time. Okay, let's comment the stream. Uh, what I'll do is I'll store this in something called as a result, and I'll convert this entire thing into a function. Define writer, and whatever input I've got here, let's change that into user underscore input, which I will be passing from my writer, and this result will be returned. Let's remove this part. I'll just say you are an AI assistant. I can also completely ignore this instructions. It's not mandatory. Okay, everything looks good. Now I'll take this. I'll run this. Function has been created. Writer of write a one line poem on cat. Okay, that is quick because it's a very short generation. Now I'll say what was my previous question. This is the beginning of our conversation, so you haven't asked any question yet. I'm happy to chat with you though. What's on your mind? Because it's not able to recall my previous question because we are not storing the history anywhere. To get rid of this, what we're going to do is let's take these messages, let's put them outside. I'll take this messages dot append this dictionary. I'll remove this comma. Okay, I'm appending my question and I'll append my result as well. The LLM generation result will also be appended. Role will be assistant. Content will be the result. Okay, let me just restart my kernel just for safety. Run all. Oh, the spelling of assistant must have been wrong. Okay, let's run this. Get this output and then let's ask what was my previous question. Okay, it kind of did. Oh, my bad. I forgot to assign this to answer. Okay, in one line, repeat what was my previous question. I'll run this. And then this, write a one line poem on cat. So you can basically get the idea. It is storing all of the previous conversations. If I go to messages, it's a global list, right? So I'm able to access it. Come on. What's wrong with you? Okay, so when I print messages, here you can see role is always alternating. System, user, assistant, user, assistant, user, assistant, user, and then assistant. So this is how we can make use of LLMs and historic conversations and get a proper response. For our project, what I'm going to do here is I'll get rid of the historic conversations part. I don't need to remember any previous conversations. Okay, I'll just say you are an AI assistant. Let's take this and store it in a different variable. Instructions equal to that thing, and I'll pass it here. I've got my user input, which is being sent here. I've got my stream equal to true commented out, which means by default it will be false. And I've got my result here, and I'm not storing it into messages. Okay, so this is a very basic structure. Now let's go ahead and convert this notebook into a Python script. To do that, first I'll create something called as instructions.py. Here I'm going to create instructions equal to. Okay, so whatever I've written in the Jupyter notebook, it's a very useless instruction anyway. So I'm going to write a detailed prompt engineered instruction for this particular project. Okay, there you go. You are an AI designed to create heart-touching poetic short stories. Please generate a heartwarming poetic short story based on a user given topic, so and so. So this is how we can give a detailed instruction. I'll save this, close it. So instead of defining it here, I can simply say from instructions import instructions. So this is how we can directly use it. PyCache. So this is something that we don't want. Let's delete it. Move to trash. Yes, please. Okay, I'll save this. Now let's start creating, or let's start converting this notebook into a Python script. Let's create a file called run.py. Now inside of this run.py, I am going to put the code of Flask, instructions, OpenAI, all the three at once. Let's see how it looks like. Okay, this is the entire code. Here you can see in the very beginning we are just writing a whole bunch of import statements, and then we are using the load.env, and then we are loading all of our environment variables, and we are creating an object of Flask. Then I'm using my OpenAI library to connect to OpenAI. I'm passing my token, my host. Let's get back to these routes later. At the very end, if the name is main, which means if I'm calling this file directly, then we will be running app.run on this particular host and on this particular port. Okay, now going up, we have two different routes. This first route is the most basic route. So whenever I go to this particular URL on this address on this port, it will be redirecting me to this part. It will simply render this template index.html. As of now we don't have this, so let's go ahead and create this index.html. So because we are using Flask here, all of the different Python frameworks like Flask, Django, Gradio, Streamlit, they all make use of a particular structure that has to be followed. That is templates folder, PLATES, and then static folder. Static should be outside of templates. Yeah, both of these should be on the same level. Okay, so inside of the templates, let's create index.html, and inside of static, I'll create CSS, JS, and images. So whatever CSS files I want to use, I'll have to put them here. Let's call it style.css, and let's call this as script.js. Next we have images. So all the different icons and all, they'll go inside of images. This is how the structure has to look like. Now let's go inside of index.html. So right now this is completely blank, but I'll say h1 hello world. Let's save it. Let's go to run.py. I'll save this whole thing. Now let's go ahead and execute it. Clear Python. Now remember, we don't want to create the PyCache folder again. So -b run.py. There you go. The Flask app has begun on this particular address. So let's go to that address. 1278000 port. You can see hello world. Now I am going to write a whole bunch of code inside of index.html. Let's Now what I'm going to do is we will change the index.html to render each and every component that we need for our app. So before we do that, we first have to understand what exactly are we going to present to the user. So let's see how we can do that. Let me just simply head over to Excalidraw. Okay, suppose this entire thing is my canvas. Let's go with a complete straight line. Okay, so this is my browser window. The most important thing, of course, is going to be an input bar where the users will type their question. Write a story about a cat. So this is what the user has typed, so we have to show that part, and we also have to give a button to send that request to the backend. So this request has to be sent to the LLM. Let's realign them properly. Okay, there you go. So this is first part. Now the next thing is, whenever we hit this button, it has to take this particular input and then put it here, and then whatever LLM is generating should be presented here. The same thing will repeat for the next questions as well. Let's put them in a different color, and let's put these in a different color. Okay, there you go. So this is how I want the structure to look like. So if I have to create a HTML page of this whole thing, I'll divide this entire segment into two parts. This will be my first part, and then oops, this will be my second part. Right, I will put this in red color. This is, let's change this to blue, or actually, you know what, let's change this to green. Okay, so these are the two different components. Now inside of this first component, I've got this part which is handling which color should I go with? Okay, this is one part and this is another part. These two blocks are going to be repeated for every single question. Let's give names to all these. I'll call this as user hyphen message. I'll call this as bot hyphen message. let's call these containers as mm, chat hyphen container, and this can be input hyphen container. Okay, so this is my chat container, inside of which I've got user input and bot user message and bot message. And inside of my input container I've got uh, let's write down these two things as well. This can be send button, and then this can be user input. Okay, so this is how I want my page layout to be. So once the user writes something here and clicks on the send button, this send button should send a request to the backend. Now this request should be handled by this route. This particular route, writer. Okay, let's visualize that part as well. We have got writer here, and the sending the request and all will be handled directly by JavaScript file. Okay, so the send button will read whatever is present inside of this input, user input. Let's give it a thickness, and it will send it to writer, and then whatever writer is giving out, let me put it here. Writer will give out a generator, and we will take this generator and we will start appending everything to the bot message because we are using streaming here. Okay, if you don't know what exactly a generator is, let's quickly cover what a generator is, how it works, and how we can use it. Back in my Jupyter notebook, let's scroll all the way down. I'll create a new cell. I'll say uh, get sentence. What this will do is line equal to, this is a sample line. Okay, and for I in line, print line, oh sorry, print I. Let's call this function get sentence. Okay, it is working as expected. It is printing all these different words one by one. Now instead of print, I'll say return I. This will give out only first word. After the first word, it is returning the entire function, so it's stopping there itself. So instead, I'll say yield I. Now this has become a generator object. To use this, I'll say my gen obj equal to this. I'm storing it here, and then let's see. In this new cell, I'll say next of my gen object t h I. So every time I run this, whatever it is yielding will be presented. Space I S space. So you can see how this is working. I'll say for I in range of 5, print next of my gen object. So you have seen that we have already completed till this space part, so it is printing everything after the space. A space SAM. So it has already completed 5 until this point because I've given the range as 5. If I run this again, it will continue from P. So I hope you understood how generator exactly works like. We are going to implement the exact same procedure in the LLM. If I go back to, where is this escalator? Yeah, there it is. Okay, so this generator will receive one single word at a time from the LLM, and each word will be appended to the user to the bot message. Let's pull it down. So in that way, a streaming response will give word by word predictions, and as the LLM predicts, that word will be sent back to the generator, and the generator will be sent back to the JavaScript, and JavaScript will present it back to the user directly. Okay, so let's go ahead and start writing code for handling all of this part. So I've already written HTML and JavaScript and CSS code for this particular project. So let me copy paste it and explain it to you line by line. See, I've already pasted the entire code here. And if I go to the very beginning, you can see the title is AI Writer, and in the link I'm giving the path to my CSS file. So instead of static folder, instead of CSS folder, we are going to use the style.css. Static CSS style.css. And now coming to the main body, at the bottom I'm importing the JavaScript as well. So static js script.js, static js script.js. When images, I've imported a whole bunch of icons as well. Okay, and in the main body you can see, let me collapse this. You can see a division called as container, which has two things. One is chat container, input container. Just like how we discussed, chat container and input container. And instead of the chat container, I've got nothing because everything will be appended directly by JavaScript. But inside of the input container, I've got one more subdivision called as input bar, which has user input and send button. As we have already defined here, user input and send button. That's it. That's the entire HTML code. Now let's head over to JavaScript file. But before we go there, if I show you here on the user input, apart from the class, I've also given a whole bunch of things. So these are the different things that I've defined. Let's go over them one by one. So first we have content editable equal to true, which means whatever I've written inside of this div should be editable. This is of course mandatory because users have to enter their input, right? So we are going to make this div as content editable, and then the placeholder that we will show them is type your message. So whenever there is nothing written by the user, we will show type your message dot dot dot. On key press, handle key press of event. So whenever a user writes something, instead of clicking on the button, they should also be able to press enter on their keyboard. So to handle that, we are using this function. On input, we are going to check input. So this check input function will do one simple activity. Whenever the user has sent a request, before sending, the submit button will be dimmed, faded out, and whenever we write something, the check input function will check if there is anything written by the user, and if it is written, if something has been written by the user, then it will automatically highlight the send button. It will simply change the CSS color, and also the on paste equal to handle paste function is very important. Whenever the user pastes something in the chat, in the input container, it should not have any formatting to it. So whenever the user pastes something inside of the user input container, it should not have any formatting. All of the fonts should be uniform, no different font sizes, no colors, no background images, nothing should be present. It should be a simple plain text. To handle all of that, we are using this particular function. And next, the send button has only one parameter here, which is on click. It will simply call the send message function. So let's go through each and every function and understand how they are working. Let me go into JS, script.js. Let's collapse all these functions for now. Okay, so handle paste, as I've said, this will take care of whatever formatting the user will paste. They will be completely wiped away and only simple plain text will be placed. Check input will simply change the background color of the send button. Handle key press, whenever the user hits enter, then we will uh, simply send the message by calling this particular function. Copy to clipboard. So one thing that I didn't mention here is, along with the bot message, I'm also giving a small button to copy whatever the LLM has given, so that we don't have to just select everything, press Ctrl C. Instead, I can just click this button to copy everything to my clipboard. So the copy to clipboard and create copy button, both of these are working hand in hand to do that functionality. And then we have a loading bot response. So as the bot is writing its story, I wanted to show, I wanted to have some sort of an indicator that it is still writing that message. So here it will have a small simple animation continuously playing as the LLM is giving out its responses. Once the LLM response is completely done, then this animation will go away. That part will be handled by this function, loading bot response. And then we have append message. So this append message will take care of adding these containers. So the user message and bot message containers. So every time we send a request, both of these containers should be appended. So that appending part is being taken care by this function. Next we have the clean input function. This is used for cleaning up the input that the user has pasted inside of the user input. So if it has any uh, different structure or Unicode character or any encrypted character, then it will become a hassle for us to handle all of it in the backend. So we are dealing with it in the JavaScript itself before sending the request. That part is being handled by the clean input. Next we have stream bot response. Uh, let's get back to this later, but first we have the send message function, which is the second most important function, I would say, or actually the most important function, and it is an async function, by the way. So let's see what is inside of it. We have a user input, send button, send icon. So we are taking all those HTML elements and we are storing them instead of JavaScript variables, and from the user input I'm just reading the value and I'm storing it inside of message. If the message is blank, just return it and close everything here itself. And here you can see we are disabling the send button, so that before getting the response, user should not be able to send a new request. That should uh, that should not, this will help us to make sure that the flow is not being broken at any given point of time. And next thing that we are doing is we are changing the icon. So for the send button we are using a arrow mark icon in the very beginning, but when the user sends out a particular input and when he clicks on the send button, as the LLM is generating the response, we will show a stop button instead of the arrow mark. Once the LLM generation is done, we are going to revert it back as well. I'll show you once we come there. Okay, here you can see append message function is being called we are passing that message that whatever user has inputted in the box, and then the class name is user hyphen message, as we discussed, user hyphen message. Okay, next we are clearing out whatever we have in the user input text. So once the user clicks on send button, this sentence, write a story about cat, this sentence will go here and this should become blank. This line will take care of making that part as blank. Next we are calling the loading bot response. So this will populate the writing animation. And here comes the star of the show, the try catch block. Here you can see try, catch, finally. Okay, so let's go one by one. So inside of the try, we are sending a request to this particular address. We are sending a post request, and the body will look like this. The key is user underscore input and the value is message. Now let's go back to run.py. Here you can see writer, it will take only post method, and I'm reading the request file, I'm reading the request data, and from that data I'm just getting the user input, and I'm creating messages along with my instructions, and I've created this simple function where it is simply reading the streaming response from the client, from the OpenAI client, and sending out the content word by word. So what I'm doing here is I'm creating a f string. So I'll say data colon space that word slash and slash n. And once all of the responses are done from the chatbot, then I'll return this part, data colon square bracket DONE. This is a very simple string, nothing fancy here. So what happens is in the JavaScript, I'll keep reading my LLM responses, but once the LLM responses are completely done, I'll receive this as the input, and once I see this capital DONE, then I'll just stop my function. I'll stop my while loop. And all of this is being stored inside of this generator. So I'm returning the entire generator, and the content type is text slash event stream. This is compulsory whenever you are handling any streaming request among HTTP requests. So for streaming we have to use this, so I'm using that, my generator. Both of these combined together are being sent out as a response. Okay, if I go back to my JavaScript, so if the response is not okay, then I'll get a message, error message. I'm printing that error message, and I'm displaying that same error message using this stream bot function. This stream bot response will create this bot message. Okay, but if it is not okay, then I'll print the error message, but if it is okay, then I'll do all of this part where I'm using a while loop to iterate through each and every word that I'm getting, and all those words will be stored inside of parsed line variable, and that word is being appended to result text. This result text is what we have inside of this bot message container. Okay, so the actual text inside of it is the result text, and I'm appending it in every iteration using a for and while loop. And once all of that is done, I'm just simply removing the loading message. All of that is in a try block, so if something fails, I'll catch that error and I'm going to show that error as it is. And finally, I'll make the user input to be editable again so that they can give a new response, new request again. And send button disabled is set to false because previously we disabled it and now we are enabling it. And the send icon source is being reverted back to this one. Okay, so that is about the entire JavaScript. run the run.py. Here we have this whole thing. I'll simply say command J. Let's expand this. Conda deactivate. Conda activate writer env. Clear. Python -b run.py. So if I don't give the -b, it is going to create a PyCache folder. I don't want that. So to keep it clean and minimal, I'm just using the -b, and I'll pass the run.py. Okay, so the server is up and running on this particular address. Let's visit it. 127.0.0.1. Okay, there you go. Write a short story on a street cat helping a house mouse. Here you can see the writing animation, and then you can see word by word it is appending, and we also have a copy icon. So once the prediction is completely done, this writing icon will go away. And also I cannot type anything here because this is disabled, and also the icon has been changed for the send button. Okay, here you can see this generation part is done, so the writing animation has gone away. Now let's ask it one more story. Clock helping a girls to understand the importance of time management. In the silence of a forgotten corner, I ticked away, constant heartbeat. Okay, you can see it's generating a story in the form of a poem in a very poetic way. Okay, it is done. Okay, so I hope you understood how exactly we can build an AI chatbot using Flask and OpenAI. If you have made it this far into the video, thank you so much for watching. Have a great day. Bye.